we have an exciting project in store for you. In this video, we will be learning how to build a motorized camera slider from a non-functional 3D printer. Elevate your videos with cinematic motion and enhance production value. So, let's dust off that neglected 3D printer and breathe new life into it by repurposing its components for this creative endeavor. Transforming a non-functional 3D printer into a motorized camera slider showcases the beauty of upcycling and repurposing technology. Using a 3D printer for constructing the camera slider might result in a slider length that is more compact compared to traditional options. However, this compact size aligns perfectly with my intended purpose. So without further ado, let's dive into the details and learn how to construct this amazing project step by step. In this video, we'll be turning an old 3D printer into a fantastic motorized camera slider, perfect for adding cinematic motion to your videos. So let's dust off that 3D printer and bring new life to it. First things first, let's discuss why I am using a 3D printer for a camera slider. This particular 3D printer is fully non-functional. Therefore, I decided to repurpose this non-functional 3D printer into our camera slider. Using a 3D printer for the camera slider may result in a minimal size of the slider's length, but it suits my purpose perfectly. I intend to use for shooting my projects and capturing close-up shots of components. The minimal length is sufficient for my needs in this context. I understand that finding scraps of 3D printers may not be easy, but this has been my personal experience that I am sharing with you. Now, if you are interested in building a camera slider, I would recommend two methods. The first method involves purchasing a manual camera slider and converting it into a motorized one, which can be achieved quite easily. The second option is to purchase aluminum profiles based on your specific lengths and acquire all the other necessary materials separately. I have displayed other materials here. These materials are similar to those used in 3D printers, so I don't need to purchase any of them. If you decide to go with the manual to motorized conversion, there are a lot of tutorial videos available on YouTube that you can search for and follow. These videos will guide you through the procedure of adding a stepper motor to your manual camera slider. Once you have watched a specific video demonstrating how to attach the stepper motor to your slider, you can then refer back to my previous videos on DIY motorized camera slider controllers. By doing so, you will be able to perfectly transform your manual camera slider into a motorized camera slider. Now, let's take a closer look at our old 3D printer. Here, I am using the Creality Ender 3S1 3D printer. While the printer itself is in a fully non-functional state beyond repair, I am fortunate to find that its stepper motors, Z-axis uprights, X-axis carriage, Y-axis carriage, and build platform are good condition. As a result, I decided to use the Y-axis build platform for our camera slider, and the Y-axis sliding movement is exceptionally smooth, which makes it absolutely perfect for my needs to do this. First, I removed the glass bed safely. Next, remove 4 of the bed leveling wheel. And taken the heated bed from the Y-axis build platform separately. Next, remove the Y-axis build platform slider rails. To do this, start by disconnecting the stepper motor and limit switch connections. Afterward, remove 6 of the screws securing the Y-axis build platform slider rails. Once the screws are removed, the Y-axis build platform slider rails will be taken apart separately. Now, I detach the camera slider's main portion. However, the Y-axis build platform required some modifications. I began first removing the Y-axis belt tension adjustment knob. Then removing timing belt from the build plate, which allowed me to easily integrate the build plate into the Y-axis slider track. Now, I have drilled a hole in the center portion of the build plate mount. we will be attaching a tripod stand to this hole. I am using a ball head tripod stand specifically that is very affordable and perfectly suitable for my camera. However, I not recommend using this ball head tripod stand for DSLR camera. If you are looking for a professional camera slider tripod head, I suggest using a different one designed specifically for professional use. But for my purposes, this tripod stand is sufficient. Next, I attached the camera quick release plate, which plays a crucial role in easily attaching our camera slider to the tripod. With the camera quick release plate installed on the underside of the Y-axis slider rail, unfortunately, when I drilled a hole in the camera quick release plate that was installed on the underside of the aluminum profile rails, the rails were damaged. This made it difficult to slide the build plate along the rails, and the plate was shaky, especially in the area around the drilled hole. As a result, the aluminum profile rails were no longer suitable for use with the slider. I replaced the Y-axis damaged rails and using the Z-axis aluminum profile rails from the same 3D printer. These rails are slightly longer than the Y-axis rails, and they fit the slider perfectly. And here, the black wiring tap is expertly tapped to cover the hole, ensuring a neat and secure installation. The final steps involved connecting the Y-axis build platform plate to the slider rails and reattaching the timing belt and Y-axis belt tension adjustment knob. Finally, I added a limit switch to both ends of the slider. Unfortunately, I didn't shoot the installation process for the limit switch, which is a somewhat lengthy procedure. Once I complete the demonstration of that process, it's worth noting that most 3D printers come with a built-in limit switch. In our case, we only needed to add one additional limit switch. Now, with the limit switch installation finished, the connection between the slider and the slider controller requires a total of 8 wires. 4 wires for the stepper motor and another 4 wires for the limit switches. To accomplish this task, I used 2 USB cables. In our previous video, the camera slider controller featured only one USB port, exclusively used for connecting the stepper motor. However, I have since added a second USB port for the purpose of connecting the limit switches. This means that the slider now connects both the stepper motor and the limit switches to a single port. To achieve this, I utilized an RJ45 LAN port, which conveniently provides 8 terminals, perfectly suited for our needs. The connecting cable between the slider and the slider controller has been intentionally made quite long. Additionally, I've used distinct colored tape to mark the USB ports on the slider for easy identification. Similarly, the 2 USB cables have been marked with the same 2 colors. This color-coded marking simplifies the process of connecting the stepper motor and limit switches to their respective USB ports. Now, I need to install the camera onto the slider. Firstly, I used my primary DSLR camera. However, when setting up the DSLR camera on my slider, I faced a small problem. The ball head tripod stand couldn't handle the weight of my DSLR camera properly. I had to apply a lot of force to adjust the ball head, and even then, it could only barely support my camera. The DSLR camera did not properly fit in this ball head tripod mount, so I didn't use the DSLR camera and instead replaced it with my DJI Osmo Pocket 2. Compared to my DSLR camera, the DJI Osmo Pocket 2 is very lightweight and compact. The ball head tripod stand for my DJI camera is perfectly suitable without any issue. Now that the camera is properly installed, let's check some test footage. For testing purposes, I recorded a series of random videos inside my laboratory. Now, let's take some test shots using the DJI Osmo Pocket 2. And these test shots were taken indoors because the slider's purpose is to shoot small space close-up shots, and it's not large enough for outdoor use. Thank you all for watching. If you have any questions or suggestions, please feel free to leave them in the comments section below or contact me in WhatsApp. My WhatsApp number is provided in the video description. Please note that I can only respond to messages, not calls. I am ready to reply anytime. Don't forget to like and subscribe to our channel for more exciting projects like this. Stay tuned for our next video, and until then, happy building!